Hello, I'm Jenny Gillard, and today we'll be speaking with Andrew Millard, Associate Professor at University of Leicester. Andy, thank you for joining us today.
No problem, nice to be here.
Andy has been studying the biology and genomics of bacteriophages for the last 25 years. Over the last 10 years, he's been studying how they can be used as alternatives to antibiotics in what is known as phage therapy. So Andy, can you begin by telling us a little bit about your work?
So I'm one of the directors, along with Martha Clokey, of the Becky Mayer Centre for Phage Research at the University of Leicester. So there's about 42, 43 researchers here now that all study bacteriophages, from basic mechanistic understanding all the way through to translation towards getting them into clinic. So bacteriophages are viruses that infect bacteria. So they were discovered over 100 years ago now. And in the 1940s, they were initially used as therapeutics in the same way as antibiotics. But due to the rise and discovery of antibiotics, they kind of took over. And they were used to some extent in Russia and Georgia and have been ever since. But with antibiotics becoming more common, there was more and more antibiotics being discovered, so phages kind of took a back burner. And with the rise of antimicrobial resistant bacteria, which are now resistant to nearly all antibiotics, alternative therapeutics are needed. And what we do is the research on bacteriophages and how these may be used as therapeutic agents or phage therapy. So we go from phage discovery all the way through trying to get them towards clinical trials, which hasn't been done yet, but that's where we're moving towards.
Fantastic. Okay, so would you say then that is your core vision for your current research?
Yeah, so the core mission or vision at the moment is to advance phage therapy and to solve future global and current problems around medicine using bacteriophages.
Brilliant. So can you walk us through your current process and how it involves Cellexis equipment?
So if we're talking about using bacteriophages, the very first thing that we do is isolate a bacteriophage, and this is done on a plate with where we get what's known as a plaque, which is a very small clearing in the center of a bacterial lawn. So we can pick this plaque, we then genome sequence, and we characterize a number of phages that come from these plaques. So we end up with a big set of phages, and then we pick the best ones based on their properties. And then the next step is to go from what we do as very small scale, where we may be looking at 5 to 10 mils, to the scale where we need to be doing tens of litres. And to be able to produce high titer phages, so that's a large number of phages per mil at large scale. So going from this 5 to 10 mil all the way up to 50 litre. So we have a number of projects at the moment that are working out how you can do this. So how things grow in 5 mil is very different from how things grow in 5 litres or 8 litres and probably 50 litres. We haven't done that yet. So Anisha and Kane are two of the people that are driving this in the centre at the moment. So they've been using the Cellexis bioreactor, which allows these disposable bags that we can reproducibly get the same conditions, and we're optimising how we produce phages at scale that can then go through the next step of purification and hopefully will end up being used as a therapeutic at some point. So at the moment, it's solving the problem of scale up of how we go from what works in 5 mil all the way to what works in 8 litres.
Fantastic. Okay, so scalability is a crucial factor to consider. How do you address this in your production process?
So going from this very small scale, we needed something that was reproducible. We also needed something that could be for, ultimately, we want these as therapeutics. And for therapeutics, you need a GMP. So while we can't do GMP here, the Cellexis machine allows GMP in the way that it can be locked down. So what we can do and what we're trying to do is optimize the process, so we can go to GMP manufacturers and say these are the conditions that work with this piece of equipment that's already used in a GMP facility, to allow them to produce bacteriophages under GMP standards that can then be used hopefully in clinical trials in the future. And it also allows us to share the protocols that we have with other groups. So we've been working with MRHA, which is a regulator in the UK in producing phage standards. So these phage standards are going to be used in sequencing experiments, and the MRHA are developing these in conjunction with us. So they have the regulatory experience and we have the phage experience. So we've optimized how we can produce a set of phages in the Selexis machine under a set of conditions. And while they're very good biologists, they didn't have any previous phage experience, but they've recently got one of these machines. So we're able to tell them the conditions, give them the phages and the bacteria, and they're now able to produce phages in the same way as we can at large scale. So these can then be incorporated into a phage standard that can then be used through a regulatory process.
Amazing. Okay, so just out of interest, if people are interested in learning more about your work, how should they get in touch?
The easiest way would be to Google Leicester Phage, and the top hit would be the Becky Mayer Centre for Phage Research, or search for Becky Mayer Centre for Phage Research on Google or LinkedIn or Twitter. You'll find us on all of those platforms, or X as it may now be called, whatever the name is. People will know.
Amazing. Oh, that's been fantastic. Thanks so much for speaking with us today, Andy. It's been lovely to see you and speak to you about your work.
No problem. It was a pleasure speaking to you.